Welcome. So, as said before, monitoring and visualization of your MikroTik ultras. So this is a monitoring deep dive, hopefully, presentation. So a little bit about me. My name is Thomas. I do network design and security, Ethernet, wireless, fiber, everything. A lot of servers and virtualization these days, and a lot of network management and monitoring, hence this presentation. I'm a MikroTik certified trainer and a certified consultant. I'm here with RF Elements. If you don't know us, you can come and visit us on our stand. So our agenda, first we are going to look a bit at SNMP, then we are going to look at Syslog. Then how to configure SNMP and Syslog on MikroTik. Some useful OIDs on MikroTik. We will look at the monitoring software, so to do dynamic SMS, and a few gotchas and things that don't work and how they work, etc. So first a little poll, pardon the pun there, if somebody notices it. I would actually like to know how many of you do not have any monitoring at all. If you can raise your hands. Okay, just one. Very good. 2 people. Okay, just a couple of people. Very good. This is a very good audience then. So, how of you do have monitoring? Come on, stretch a bit. Very good. Okay, very good. So, those of you that have monitoring, keep those hands up. Come on, hands up, hands up, hands up. Okay, so keep the hands up if you actually monitor CPU, RAM, and hard drive usage. If you actually monitor traffic on all of your interfaces, and here I'm saying packets per second and bits per second, okay, less hands. If you actually have proper thresholds and actually monitor these values with thresholds and generate proper alerts, okay, so now we have, okay, still a few hands, okay. If you have email and SMS alerts on threshold violation, okay, about 20 people still. Okay, so this was level 1. You passed level 1. Let's go to level 2. So keep your hands up if you collect SNMP traps and alert based on those SNMP traps. And if you collect Syslog and alert based on Syslog. How are we doing? Okay, about 10, 11 people, I would guess. Okay, so that was level 2. And the special level, level maps. So how many of you actually have maps of on your network? This doesn't matter on the previous stuff. So raise your hands up if you have maps. Okay, a lot of people can. Okay, and are those maps still actually accurate? Because networks change every day. So are your maps actually accurate? Okay, less hands. Do you have separate layer 2 and separate layer 3 maps? Because those are 2 completely different and separate things. Okay, very good. We have a couple of people in the back. All right. And do you have dynamic layer 2 and layer 3 maps that actually adapt to your environment? And if you change something, they actually adapt dynamically. Anybody? 1 person, 2 people. Good. All right, so the rest of you, you have at least something to learn from this presentation, I hope. So, why all these questions and why did we do this little poll in the beginning here? Because monitoring is amongst the most important things in networking and in IT in general. And I really feel like this topic gets underplayed and undervalued a lot. So the monitoring is the difference between I think everything is okay and I think my network is working and I know everything is okay for a fact. And it might not seem like a lot, but this is a huge difference, and it allows you to sleep at night much better. So these questions were actually aimed at a few things. First of all, that the monitoring system that doesn't monitor necessary things is not very useful. Hence all of those questions, if you monitor this and this, etc. And a proper monitoring system needs to actually be independent, which means that you should not even have to look at your monitoring system unless there is a problem. The system should tell you when there is a problem, and you should look at it only when there is a problem. The monitoring system that you constantly have to look at and constantly have to monitor, so monitoring the monitoring system, that's not a thing that you want to do. And regarding maps, and why I was talking about maps, network maps are actually a very useful addition to your documentation. And why the addition there is in bold letters? Because network maps are not your documentation. We all have network documentation, right? Which is not maps, right? Everybody? So network maps actually help you visualize your network very well and help visualize breakpoints. They help new employees to understand your network faster and especially help consultants help you faster. But network maps are not documentation per se. So what are we actually doing here at this presentation? So hopefully the outcome of this presentation is that all of you by the end will know enough, at least basics, to have all of these nice things. So let's actually start with some theory, and this is the dry part of the presentation, so you will fall asleep. I will not blame you because this is a bit technical. And if you like that, then very good. So SNMP, Simple Network Management Protocol Basics. So SNMP is a layer 7 protocol used for management of networking devices. And it is used to actually get management information and data and statistics from the devices. And SNMP can actually be used to set configuration of the device as well. But what you need to actually remember is that for this presentation, we use SNMP to collect data like CPU usage, like CPU statistics, etc. from our MikroTik devices. If you remember just this one sentence from this slide, you'll be okay. So how SNMP works, and this is a totally technically correct diagram, if you can see it. It took all of my MS Paint skills to make this. So the device runs an SNMP agent. And this is a piece of software providing the SNMP service. You could call it an SNMP server, but please don't, because that's not correct. But just to help you understand, SNMP agent is simply another service that runs inside of your router OS, inside of the operating system. Then you have the network management software. So we have an NMS, network management, network monitoring system. And we also call this an SNMP manager, and it retrieves information from the device. And it also has an SNMP trap collector. So this trap collector is simply there to receive traps from the device. So it's a service that runs inside of your software. And again, you can see the perfectly technically correct representation of software right there. So SNMP set and get, and what are these things? So SNMP, as we said, can be used to get information from a device, and this is the most common usage of SNMP, of course. But very often forgotten, SNMP can also be used to set some device configuration. These are just a few examples. It can actually turn the interfaces on and off. It can manage the SNMP agent itself, so it can actually change SNMP credentials using SNMP. It can reboot the device and many other things. But this is out of scope for this presentation. Just please remember that SNMP is actually fully read and write and can be used that way. So again, completely technically accurate graph. This is how it actually works. So the NMS software actually sends get requests or set requests to the device's SNMP agent, and the SNMP agent responds to those requests. And the SNMP agents can also send traps to the trap receiver inside of the NMS software. Just a note here that responses are not actually traps. Responses are just responses back into those requests. Traps are a separate thing. Okay, so that's all and easy. You say that's SNMP basics. It's how all client-server software works, pretty much. So let's get a bit more technical. So there are 3 versions of SNMP, version 1, version 2C, and version 3. So let's take a closer look at these 3 versions. So SNMP v1, and on purpose I put a year there, SNMP version 1 is from 1988. Okay, I guess most of the people here were born in that year already, but that's pretty old. So that was the first standardized SNMP version. And why I'm saying that it's really old is simply because don't use it. And if somebody still uses SNMP v1, please stop. It's extremely old. Don't do it anymore. So it was the first standardized version. Authentication using a community string, which is basically a pre-shared key. And you can have separate communities for get and set, so you can have separate pre-shared keys for get and set. And it was a great start, but for 1988 it was a great start, but today we are 27 or something years later, so it has many issues for usage today, and that's mainly 32-bit counters. So maximal 32-bit unsigned integer is 4 gigabyte. So if you have a 1 gigabit interface, the counter will actually overflow in 4 seconds. Hence, please do not use SNMP version 1 anymore, under any circumstance, hopefully. So let's move to SNMP version 2C. If you are wondering, yes, there was an SNMP version 2, but today pretty much nobody uses that. There is only SNMP version 2C. So it's SNMP getting better. There are a lot of performance improvements. You have bulk, bulk, and stuff that we will get into in a second. And mainly support for 64-bit counters. Yay, it doesn't overflow anymore. And why the C in the name? Because it still uses a community string for authentication. So that's version 2 community. And now we finally get to the good stuff, SNMP version 3, which keeps all the good things from version 2C, but with a new security model. So it actually supports full username password authentication, supports integrity message check, verification, MD5, or SAH1. It actually supports message encryption, and it has 3 security models. As I said, if we weren't technical enough before, I hope this is getting a bit better now by this point. So you actually have 3 security modes. No authentication, no privacy, so no integrity check, no encryption. This is pretty much useless, so MikroTik or any other devices, please don't use this if you don't have to. Authentication, no privacy, this is a good one, so you have integrity check, so the message is actually protected against spoofing, against injection, etc., etc. But you don't have encryption, which can be good, because encryption, of course, is CPU intensive. And then you have authentication and privacy, which provides integrity check of the message and encryption, but this is CPU heavy, of course, because of the encryption. So SNMP best practice, what to do with all of these versions. Again, if you remember nothing else from this, just remember this slide. Do not use version 1 under any circumstance. Every device today, I would hope, supports at least version 2C. So, but still, use version 2C only if you have to. And use version 3, probably the best to use authentication, no privacy. So you don't do encryption directly in the SNMP engine. But then run the SNMP communication over VPN, not over public internet. If you have to run SNMP over public internet, use, of course, version 3 with encryption. But generally, you should be using authentication, no privacy, and then encrypt only the transport link which leads over the internet. So this is the basic stuff. Do a site-to-site VPN, and then poll all your devices using SNMP without the additional encryption inside of SNMP, since your communication is already secured by the VPN. I'm not saying the encryption inside of SNMP isn't good, or you shouldn't use it. It's completely valid, and it's good. It's AES 128 CBC, so it's good. But then again, just to avoid the unnecessary load on the CPUs, if it's only, in my opinion, it should only be used in certain situations, not always. So the best mode, authentication, no privacy. So let's move a bit forward. Again, we are talking about SNMP and what it is, and about SNMP basics. So let's talk about MIBs, MIBs, Management Information Bases. So MIBs actually describe data and its organization inside of the SNMP structures. And why do they exist? Actually, SNMP structure is made to be easily expandable, extensible by the MIBs, because each vendor may need to expose different things over SNMP. For example, a server doesn't need to expose wireless access point information, but a MikroTik device, if it's running an access point, you want those information to be there inside of SNMP. So MIBs actually make the system, the SNMP system, actually quite user-friendly and quite easily expandable. So what is this MIB that I'm talking about? It's just a file you give to your NMS, Network Monitoring Management System. And the NMS will use this file to make the information you get from SNMP more useful. Again, that's the simple version. So what's the difference with and without having MIBs? So this is a screenshot without having any MIBs, and you can see we just have a bunch of numbers and some types and then some values, which we, what do you do with that? I don't know what that is. So this is how it looks without MIBs, and this is how it actually looks with MIBs. So this is a big difference because we can now see that those numbers that we had before are actually a UPS exposing some data to us. And for example, we can see that this number that was there before that we didn't have a clue what it was is actually UPS battery temperature given in tenths of a Celsius degree. So this all information is pulled from a MIB. That's why I said that basically MIBs, you give them to your LMS and they make the information you go from SNMP more useful by giving you context and giving you details about the data that's exposed over SNMP. So how data is structured in SNMP? So data or information in SNMP is structured as a tree. And as you work with SNMP, you will slowly learn what's located where inside of the SNMP tree. And just a few examples how it actually looks. So you have the root node, which is .1, and then you have the tree structure expanding. So .1, .3, .6, etc. is basic system information. Then if you continue down that tree, but through a different branch, you can see .1, .3 is the same, and even .6 is the same, and it actually splits somewhere down here. This is the basic interface table. And then this sequence inside of the tree, so this branching sequence inside of the SNMP tree is the advanced interface table. Don't worry if you don't understand this, we'll cover it a bit more in a few seconds. So OIDs, object identifiers. So these are actually the paths inside of the SNMP tree, you could say. So these are called the OIDs. So what we've been seeing up until now, these sequences of numbers are actually OIDs. So this sequence of numbers, we could say, is the basic system information OID. And there are many OIDs for many things. And we will look at some useful OIDs soon. One more thing which I would like to cover or explain is SNMP walking. So SNMP walking refers to getting all the data in the tree under a certain OID. So if you can imagine the tree structure, under this OID, there can be some more information, more leaves, more branches of the tree. So if I say that I'm doing an SNMP walk, I'm referring to actually getting all the information under the specific OID inside of the SNMP tree. So for example, walking this OID would give me the basic information about the device, since we said that this OID is for the basic system information. So walking.1, which is the root of the tree, which is the most upper node, would actually dump all the available information from the device over SNMP. Don't do this, it will take ages and possibly kill the CPU in your device, since the whole SNMP tree contains a lot of information, possibly millions of records. Alright, so let's do an actual SNMP walk, or let's look at an example of an SNMP walk. So this OID that we've been mentioning up until now, the basic system information OID, if we do a walk of this OID, and you can see here I have the information of what is what from the MIB, from the MIB, I can see that the bulk of this particular OID gives me a few information. First of all, what this device is, my email, so the SNMP contact, the location, and you can see here system location, this is this one, so it's on my test bench, system name, this is this one, system contact, this is this one, etc. So what you can see here is simply a walk of this OID, and I have the MIB, so I can see all the information, and this down here is the result of the walk giving me the actual data or information about the device. Alright, so that's SNMP basics. Let's look at a bit more advanced stuff yet again, which is SNMP tables. Data in SNMP is organized in tables. here is an example of an actual table. So we have an index, and then we have some columns inside of the table giving us some particular information. So how SNMP tables actually work? There is usually a main table index, OID. For example, this OID is the interface table index. So for example, here, if we hold the index, it will give us 1 through 7, which means we have 7 interfaces of this router. And we can then hold different OIDs to get different data about each interface. So index simply ensures that we know which data belongs to which interface. Like here, if we hold this OID, we will get the index from 1 to 7. And then if we hold this OID, because this OID is the interface index, and this OID is the interface description, and inside of the interface description vault, we can see the suffixes, which are really the index here. So we know that interface 1 has name Ethernet 1, and the MTU value is 1500. And just like this, you can construct an SNMP table inside of your software that looks like this. This is what it basically is, put into a single table. Okay, so that was too complicated, too much information. Why are we even talking about this? I admit, don't worry, most of this is handled internally by your NMS, but it's still good to know how it actually functions once you get into monitoring everything pretty much, which is the point of this presentation. So you just have to know, again, if you take nothing else from this part of the presentation, just know that certain data is available at a certain OID. And you can insert your favorite search engine here to find the OID of the data you're looking for. So just type in your question into whatever search engine, being OID for disk usage, and it will come up with an OID you can use. Alright, so that's it for SNMP. Now let's look at Syslog. How many people do we have asleep here yet? Oh, there is, okay, 1, 2, no, they are raising their hands, so they are not asleep. Good job, people. Alright, so Syslog. And Syslog is easy, don't worry, we won't be talking for another 20 minutes about Syslog, because Syslog is easy. And on a basic level, Syslog is just a standard to transfer logs over the network. So using Syslog, you can actually dump all your logs from your device that your device generates into an NMS. And this is very useful, and you should do it. So why? Why Syslog? Why should I do it? You have logs which are stored locally in your device. This is a simple MikroTik log. You can see that some links went up and down, your CPU is refreshed, etc. But these logs are lost on reboot because they are stored in device's memory. Yes, you could configure logs to go into the device's hard drive, but what if that dies? So if a device goes down, if the logs are in the memory, it is useful to see why the device went down, and the logs can actually tell you. So an NMS can keep a long history of logs, and the device has limited memory. And like I said, even if you dump your logs to a file on the device's hard drive, that is, again, very limited. And also, with the right network monitoring management system, you can really do nice searching and filtering of logs. And you can do it instantly. You type a certain search query into the NMS, and it will give you all the logs matching from all of your devices. So Syslog is very useful. And like I mentioned before, you can actually generate alerts and alarms based on the logs. So for example, if an invalid login happens more than 3 times in 5 minutes, send me an email. This probably is a very nice thing to have. So how many of you have seen logs like this? Yeah. So this is bad, and you should probably know when this is happening. But unless you log into this device, you wouldn't know and you wouldn't see this. So that's why it is very useful to dump your Syslog into the NMS, so your log into the NMS using Syslog. And then the NMS can actually generate alerts when this happens. Which, again, you should probably know if this is happening, because this is not good. All right, so let's look at some configuration. So configuring SNMP on MikroTik. This is SNMP version 3, made easy. So you can just copy all of this, replace what's in red, paste it into your MikroTik CLI, so over SSH or whatever, and boom, you have SNMP version 3 ready. With the username and password that are here, and this is using authorization no encryption. And the slides will be posted publicly after the presentation, so you can copy this. Okay, so configuring Syslog on MikroTik. This is made very easy as well. Apparently, spell check has made it east. Okay, so that's supposed to be Syslog made easy. So you can see you can just paste all of this into your MikroTik again, change this for your NMS IP address, and there you go. And your MikroTiks will now actually dump their logs onto the Syslog server. So like I promised, here are some useful OIDs on MikroTik. For example, CPU usage of each individual CPU core is located on this OID. Router OS version is right here at this OID. Health table, so temperatures, voltages, voltage, so power usage, all the different temperature sensors that MikroTik has right here under this. This is actually a table, so the three under this OID, if you do a Volk, you will see all of it. Storage table, so you can see disk and RAM usage under this OID, and interface table, so you can see interface data. There is a lot of interface data and statistics under this OID, including bytes per second and packets per second transferred, received, and sent on an interface. Useful wireless OIDs, for example, wireless card frequency is right here. Total number of wireless clients. If you are in access point mode, you can get a lot of per client data, like signal strength on every individual chain, signal to noise ratios, everything, speed of every single user after modulation. There is a lot of data under this OID. And you can even get useful things like the number of PPP clients for your PPP only concentrators or for your VPN concentrators. That's under this OID. And these are just a few examples. There is a lot of things inside of SNMP, of course. And if you want to see everything that MikroTik provides that's MikroTik specific, you simply download MikroTik's MIB, MikroTik's MIB. You plug that MIB into the NMS, and you will be able to see all of the data that the MikroTik could provide. So what should you actually aim for with your monitoring system? And this is just a recap of the things that we said before. First of all, you should aim to have monitoring. So that's the most important thing. Without monitoring, you just get it, please, do me a favor, and you will thank me later. And you should aim to collect CPU, RAM, hard drive usage, traffic on interfaces on your devices, not just MikroTiks, your server, your servers, your routers, your switches, everything. Monitor, of course, temperature, voltage, and actual VAT, power usage of your boards, and to actually have proper thresholds on all of these boards and generate alerts on threshold violation. Then it would be, of course, useful to have email alerts on certain alarms and on certain thresholds, and even have SMS text message alerting on alarms with high severity. So if your core router is down, or one of your two core routers is down, because you should have redundancy, so 2 core routers, please. So if one of those is down, you definitely want to get a text message. If you only have one, you are probably not going to get that text message because it's not going to get out to the internet. So that was, again, our aim level 1, and our aim level 2, to have more nice things like collect SNMP traps, and then alert based on those SNMP traps, collect syslog and alert based on syslog messages and syslog severity, and a really nice thing to have is dynamic layer 2 and layer 3 maps. So here we are talking, again, this is all using SNMP, so a network monitoring system should actually be topology aware and should be able to get enough things from your SNMP, and it can, to actually generate dynamic layer 2 and layer 3 maps of your topology. So if you add a device, the NMS will actually dynamically add the device and connect it properly topologically onto the map. And we will look at this in a second. So what I'm trying to say is monitor all the things, monitor everything. So why all of this? Why did we even bother? Because this sounds like a lot of work, right? So why do we bother? Just to have the peace of mind and to know for a fact that your network is fine, not just assume that your network is fine. Because if you just assume your network is fine and it's based on no fact, then what's the truth? So, and we really need to have an independent system, or you need to have an independent system that will let you know when something is wrong, rather than you having to look at it and monitor the monitoring system. So now we will take a look at some NMSs and how to achieve all of this. And just to say, there are many NMSs, and you have many choices in this regard. I have actually took two NMSs to show you here on this presentation. So first of all is the Dude, which is a MikroTik NMS. It's free. It's very easy to pick up and learn, and very fast to get started and get some results. So let's do a little Dude demo. If my VPN allows me to connect. All right, here we go. So this is the Dude. You have probably seen it even in the previous presentation. And if you've been with MikroTik for any amount of time, hopefully you've seen the Dude by now. It's going to connect, get some stuff. This will probably take a minute because this Dude installation is quite large. Come on, getting stuff. And like I said, you have many options here, many NMSs. But one thing I want to point about the Dude is, like I said, the simplicity. It's completely graphic, so it's a completely GUI-driven experience. It's really fast and easy to set up, and the actual amount of work, the actual amount, the price-performance ratio with Dude, so to speak, is really high. So you simply can have it completely running in about an hour, and great, you have at least some monitoring. It's still downloading and connecting. Courtesy of Conference Internet. Next slide. There we go. We're getting there. All right, so this is an example Dude installation. This is actually kind of our network. So we can see that we have a bunch of devices here. And we have two uplinks. We have some VPN connected here. This is a wireless link, and there is a lot of stuff, and things are green and blue. Yay. A couple of things are red, so that's probably not good. So what I'm trying to say is that just looking at this, you can already see with a single glance that this is very graphical. It's actually, like I said, very easy to set up. And the Dude can do some pretty powerful monitoring. If you, for example, look at this network, it's actually not giving us the information about the UPS in our rack because it's 64-bit counters. Next slide will explain why this is not working. But you can see that really easily you can see the CPU usage, memory usage, hard drive usage of a couple of servers here. You can see some switches again. This is our infrastructure basically. Let's do. So this probably would take you, if you didn't know Dude at all, this would take you, I would say, 2 to 3 hours to make something like this, which is a pretty good result for a fast time investment. And yeah, you can see it has nice graphs, it has history, it has a lot of things. And the Dude can even do things like Syslog collection, which we mentioned. But there are some disadvantages. And I'm not going to spend a lot of time on the Dude because, like I said, probably most of you have already seen it. If not, it's really easy to pick up. So, yes, the Dude has some disadvantages though. And it's no longer maintained. So the last release of the Dude was about 4 years ago. Ever since then, MikroTik has been saying it's not dead, it will be patched. It's still alive, but the fact is that it has not been patched for about 4 years now. There are no templates. It's really tedious to set up some things like Syslog. It works, it's there and it does its job, but it's tedious to set up. Also, custom monitoring and stuff like that is tedious to set up. 64-bit counters break a lot. 2 GB database limit, and it's a node size, SQLite database, Windows only, blah, blah, blah. I could go on. Like I said, it's a really good system, fast to learn, fast to do, but it has many faults. And that's why I actually chose another LMS to show you, which is NetXMS. NetXMS is an enterprise-grade LMS. It's free and open source software. It's extremely powerful and extremely versatile. If you have never heard of NetXMS before, I hope what I show you you will like. Just to say here, I actually reviewed Nagios, Zabbix, Xenos, Observium, and a lot of network monitoring solutions. And NetXMS is the one I particularly chose and like, so I encourage you to take a look into it. So I think I don't need to read all of this. Yeah, Linux, Windows, Solaris, blah, 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 full multi-platform, multi-database, unified web and dedicated client, templates, blah, blah, blah. It does a lot of stuff. So I want to show you NetXMS with MikroTik and the power you can have using MikroTik devices and a proper NMS system. So this is our NetXMS system. And there we go. You can see I have a bunch of devices here. Again, most of the things are green, some are other colors. And I'll just step down here so it's easier. So first of all, a few things I want to show you, which is why I mentioned SNMP and monitoring. If we go into our MikroTik devices, so router OS, you can see I have a bunch of them here. Let's look at our IPsec access concentrator. And you can see that on our IPsec access concentrator, I actually monitor the CPU, come on mouse, the CPU average load for both cores, how many cores the router has, CPU usage on every single core, board temperature, CPU temperature, all the health variables, how many active PPP clients there are, RAM size, usage, router OS version, a lot of things. And as you can see, actual packets per second and bits per second on every single interface. So this is probably enough. I'm not saying I couldn't do better. I could monitor many more things. But these are the basics that you at least should aim to monitor. And actually have thresholds and alarms and alerts and SMS, text messages, etc. on threshold violation. What I want to show you is these things, which are some nice graphs you can see here. So RAM, this is when I connected my VPN client from here for this presentation, so you can see the number of VPN clients went up. So here are some nice graphs. And you can see that we monitor every single interface on this device. So you can see this is pulled straight from SNMP, being the SNMP interface table. And we actually monitor every single interface on this router, and we expect every single interface to be in a specified state. So if somebody unplugs one of my interfaces, I definitely want to know. And if somebody plugs in a cable somewhere that's not supposed to be there, I also definitely want to know. So you can see we monitor every single interface on our devices, and we just take care to know how our network is. And as I said, a lot of other things. And you can see if I do here this, you can see that we actually have thresholds on, let's say, CPU usage, or let's say RAM usage. So from RAM usage, for example, you have thresholds. This is at 90%, so if RAM usage on our MikroTik goes above 90%, we get an alert. I get a text message, and I know that I have to do something about it. This again goes back into saying that I shouldn't even look at this system unless something is wrong. That's the proper monitoring system. I don't look at it, at least it lets me know I need to look at it. So, for example, we can do useful things like look at the version of all our router-less devices. So let's do MikroTik, actually versions router-less. So you can see that I have a bunch of MikroTik devices here, and I collect from SNMP the version of all of my devices, and you can see that most of my devices are on version 25 or 24. One is even on 6.1 because that's our edge router, and I don't mess with that. It works, so I don't touch it. And our BPPO access concentrator is on 6.7. Again, it works, so I don't touch it. Which, by the way, I recommend. It's a great thing. If it works, don't touch it. You know, that's the general IT rule. I recommend following that. It works. So you can see that just with a few clicks, with the proper NMS, and having all this SNMP data from my MikroTiks, I can do wonderful, wonderful things. But what I mentioned about maps and dynamic maps. So let's look at the dynamic layer 3 of our network. So this is completely dynamic. I haven't put any of the nodes, any of the things, any of the links you see there on there. This is all actually gathered from the MikroTik's routing table over SNMP. So the NMS actually is completely topologically aware. It knows what's connected where. It knows the routing tables of every single device. It knows the layer 2 connections of every single device. Again, MikroTik exposes these data over SNMP. So this is a completely dynamically constructed map. If I press refresh here, this will take a second because it's over VPN. It will actually completely rebuild. You can see it. Let's do layout. So you can see if I press refresh, it will rebuild the whole network every single time. That's how you can say it's dynamic. And you can see it even knows ECMP, equal cost multipath links. So this is a redundant link. It even knows from the routing information from my MikroTik devices, this is all MikroTik routers, how to actually construct this topology. So completely dynamic layer 3 maps, and also completely dynamic layer 2 maps. So what you can see here is a dynamic layer 2 map. Let me just get rid of all these nodes. You can see this is a dynamic layer 2 map of my topology. Again, layer 2 maps are very different from layer 3 maps because of VLANs. We have many VLANs inside of our system. Therefore, visualizing the topology on layer 2 and on layer 3 can be very useful for debugging because the topology is very different on layer 2 than on layer 3. For example, you can see that on layer 2, we have 4 core switches which are connected in a full mesh. You can see these 4 switches have a full mesh in between them. And then we have some ESXi servers which are also connected redundantly to 2 core switches. So this is a layer 2. But on layer 3, this is the core. It's a star topology of the core. So you can see here how visualizing this can help me to understand my topology, or if I have a new employee, help him understand this topology much faster. And again, this is all data from SNMP. I could show you a few more things, I guess. Again, updating my system can be as easy as clicking on the device and running a certain tool. For example, opening Winbox, one click, and I think that just opened on the other screen. There we go, now I'm connecting to my actual MikroTik. So you can see a powerful NMS combined with a powerful system like MikroTik can do a lot of things. Actually, one really cool thing I would like to show you is this. Let's say I have, let's do this one, AP Thomas, so my access point. Where is this located inside of my network? I know, but a new hire or a consultant might have no idea. So it's really nice to just be able to click on this. There is a command here which says find switch port, and magically the NMS will tell me exactly where this device is connected in my network. Again, this is because the NMS is completely topologically aware. It knows the ARP tables of every single device, it knows the IP routing of every single device, etc., etc. So I can actually see that this device, access point Thomas, is connected on Ether 1 to switch rec 1 on port 14. All right, very good. Let's find where, let's say, router 2 of wireless LAN 1S switch port. There we go. Okay, so this is connecting on the same switch to Ethernet port 32. And also what I would like to show you, we can find a wireless access point. So let's do networking, point to multi-point access points. And let's actually do topology and wireless stations. And you can see even, again, MikroTik exposes this information over SNMP. So you can actually see every single wireless station connected to this access point, which SSID is connected on, etc. So let's take things a little further, because there is a button here which says find IP address. And again, for a new employee, I simply tell him, you know, this IP address has been causing us trouble. It has too much traffic going in or out, it's spamming or something. Go and find that device, where it is, what it is. I just know the IP address, go and solve it. So let's put in an IP address. Let's do 10.3.199. Here's my computer. And magically, it finds my computer right there by its IP address. Again, this is because the NMS is completely topologically aware. But even better, let's find the PPPoE customer, which doesn't have an IP address, or rather it has, but it's a /32, since PPPoE is a point-to-point tunnel. So even if I knew the IP address, it doesn't tell me much because it's a PPPoE thing. So NMS would see the PPPoE connection being terminated on the access concentrator, and therefore I would see the access concentrator as the owner of that IP address. So there is a button here. Okay, first of all, let's find a PPPoE customer, which can be used for the experiment. Let's look at, where's the PPPoE? Here, access concentrator only connect using Vbox. This is kind of hard because I don't have the screens cloned. Okay, so I will just find one PPPoE customer, and I will not show you. Let's do this one. So I just know the MAC address. And again, let's say that this is a case where a certain MAC address has been sending out a lot of layer 2 broadcast. So it's spamming my network, it's layer 2 broadcast spam, I have no idea what the IP address is, it's an attacker, and I want to find it as fast as I can and get rid of this attacker. So I only know the MAC address, I put it in there, I press OK. And magically, the NMS will show me that this MAC address, I don't know what it is, it doesn't have an IP address, but it lives on this MikroTik access point, on this SSID, and it's a wireless client. So again, you can see how powerful this can be. With just a couple of clicks, I can find any IP address or any MAC address inside of my network, and right away I can know where it's connected, and I can go and investigate, disconnect, etc., etc. So we have gone through maps, we have gone through alerts, we have gone through some useful things. Also, what I would like to mention is that you can actually have really nice things like one button device identification and applying of the templates and of the monitoring. So you can see I have a MikroTik template here, so router OS or switch OS, MikroTik devices, both of them. And if I add a new device into this NMS, it is capable of automatically discovering the device over SNMP, figuring out what the device type is, and applying correct monitoring items, correct templates to this device. So the end effect is that you just give the NMS an IP address, and it will automatically find what needs to be monitored, what needs to be thresholded, what are the thresholds, etc., etc. So it's a completely automatic, easy-to-do system. All by the power of SNMP. All right, so let's continue. Okay, so a few gotchas. So there have been a lot of SNMP bugs in RouterOS. For example, bulk doesn't work in these versions. Version 3 timing problems make version 3 unusable on these versions. Storage was missing completely in SNMP in these versions. I could go on. But what I'm trying to say here is that always use the newest RouterOS version and make sure to also use the latest router boot version. Because some SNMP bugs are actually fixed by changes in router boot. So router boot upgrades actually fix these bugs in SNMP in RouterOS. So just remember that if something is not working, just use the newest version and it will most probably work. But yeah, you are not safe even right now because in 6.27 there is a bug that causes routing table not being reported over SNMP in certain cases. So this will be fixed in 6.29. Just watch out, not at 6.28, which will be coming out next, but in 6.29. So make sure to upgrade to 6.29. There are SNMP upgrades in there. And one important thing is that storage. In older versions, older than around 6.15, storage was actually reported differently on x86 RouterOS and on router boards. So this basically meant you needed separate monitoring templates for x86 and router boards prior to this version. So this has since been fixed, but watch out for this if you use older RouterOS versions. So if your NMS is not monitoring the storage usage on your router board, and the RouterOS version is older than this, then you need to go and look at it, see how it's implemented in the old implementation of SNMP, and create a separate template. So what can still be improved? There are still things that can be improved. For example, MikroTik does currently not support LLDP. It does not support STP MIB and BGP MIB. This is a big one, and this is a big one. So it would be really nice. I don't know if there is somebody from MikroTik here. If you are, these are my feature requests. And that's basically it. If you like this presentation, I have a couple more presentations on TikTok you can look at. And yes, if you have any questions, either ask now or find me after the presentation.